How is a windmill like a conformational isomer? We looked at isomers earlier. Now we will look at conformational isomers. Conformational isomers have the same formula, same structure, but the difference is the rotation along a carbon-carbon sigma bond. So we will look at conformational isomers of alkane chains and rings, and we want to represent those conformational isomers using skeletal structures, Newman projections, wedge and dash, and sawhorse projections. Then we want to identify the most stable conformational isomer. A molecular model using balls and sticks represents a molecule as a static structure, but molecules are not static structures. See these two YouTube simulations of drugs entering the binding sites of protein. Molecular motors involve the dynamics of motion along a bond axis. See how the motor axis moves to rotate the rotor axis. Molecular switches involve conformational change. Take a look at the top structure and see if you can identify the bond or bonds that rotate to form the bottom structure. This picture shows how a conformational change is involved when HIV infects a cell. Conformational analysis begins with bonds vibrating. Imagine two balls connect together by a spring. That bond can either stretch or bend. Wiggle your favorite bobblehead doll to imagine the stretching and bending. A molecule has an ideal shape or angle, but repulsion of electrons from either lone pairs or bonding pairs strains or distorts the molecule and destabilizes, that is, makes it less stable. The two types of effects that destabilize a molecule are steric effects, which are through space, and inductive effects, which are through bonds. So stop the video and read about the 4 types of steric strain that destabilize a molecule. Inductive effects are through bonds, steric effects are through space, so stop the video and identify the picture which is like a steric effect. So the answer is, we've all experienced a close talker in social situations in which they get too close to your face. Let's take a look at ethane. Steric strain between two hydrogens cause rotation around the carbon-carbon sigma bond. The staggered conformational isomer, or conformer, is more stable or lower in energy than the eclipsed conformer. In the staggered conformer, the hydrogens are farther apart than in the eclipsed. We can represent each conformer by using a wedge and dash, sawhorse, or Newman projection. Let's practice looking at different representations of conformers. Stop the video and identify the most stable conformer of ethane and propane. So the answers are, more practice. Identify the most stable conformer of butane and then for isobutane. So stop the video and think about that for a minute. So the answers are, for butane there's 2 staggered conformers. Note that the anti-conformer is more stable than the gauche. For isobutane, H and J are both staggered isomers, but they're the same. Let's practice drawing the different ways to represent conformational isomers. So stop the video and draw the conformers of these 2 compounds and then identify the most stable conformer. And the answer is, note that the most stable isomer will be the staggered conformer. The legalization of marijuana is spurring research and new market opportunities. THC produces the intense psychogenic effects, but cannabidiol does not. So CBD is being studied for possible analgesic, anti-inflammatory, and anti-anxiety properties. Compare CBD to THC. Which bond rotates in CBD to form THC? Stop the video and think about that for a minute. So the bond which rotates like in a conformational isomer is